Okay guys, so I'm going to do my best here to make this video for you. It's difficult to do it like this. It's difficult to do it anyway. But anyways, let's talk about conventional two-strokes first. Conventional two-strokes all work the same with minor differences here and there, such as some have reeds while others operate based on piston porting. Piston ported engines rely on the intake port being opened and closed by the piston itself, while reed valve engines use the reeds to perform the opening and closing of the intake. Okay, the benefit of reeds is that you can get more fuel into your crankcase and then capture it because, the reeds close and it traps all the fuel and air mixture. Whereas that same situation with a piston ported engine, if you pull in too much air and fuel, well, then the piston as it comes down is just going to push it right back out the intake, right? The reeds would close and stop it. So that's a big benefit for the reeds. However, the drawback of the reeds is that they have a low RPM level before they begin to flutter. I was the same as many of you guys out there. You're like, well, if they're used in motocross engines, I even remember having a conversation with Aaron about this. If they're used in modern motocross engines, they must be good, right? Well, they are good because a modern motocross two-stroke is only, I think, max 9,000 RPMs, maybe 10,000 RPMs, maybe, but I doubt it. Probably they build their power from about 3,000 RPM up to about 7,000 or 8,000 RPMs, honestly. So, but a chainsaw, we're going all the way up to 12,000, 13,000 RPMs, and so the reeds, they flutter and they don't fully close. And so in our situation with the chainsaws, it's a better setup to actually utilize a piston porting. All right. So as you can see in this animation here, as the piston is going up and down, it is in fact closing and opening the ports. It's simply being there. It's standing in front of a doorway and then it moves. And it's standing in front of a doorway and then it moves. And this is the opening and closing of the ports. And that is what a piston ported engine does. All right, now, okay, let's talk about the general, the explanation of the conventional two-stroke transfers, okay? So we're pulling in, basically whenever your piston goes up, it creates a pressure drop. And in that void of pressure, the outside pressure moves in. A lot of people like to think that they are sucking, and in a way they kind of are, but it's not. It is creating movement, okay? It is literally creating movement. It's not creating suction. Whenever this piston goes up, all of the air that was underneath it follows it. And then that means all the air outside of the carburetor follows that and gets drawn into the crankcase area. So that's how we load up our crankcase. Then the piston comes back down and it pushes all of that up to the top, right, above the piston. So, and this brings in one of the big important things of the 5 series saws, and that is scavenging. In a conventional two-stroke, all of the scavenging happens with the fresh fuel and air mixture. Now, I guess scavenging should be explained a little bit. What scavenging is that area above the piston, your combustion chamber, or just simply the upper cylinder area, is going to be flooded with exhaust gases or spent gases. And we need to get those moving out the exhaust. And in order to do that, right, you could just sit around and wait and they would all just naturally go, right? But, or at least most of it would. But you can also push new charge into that combustion chamber up towards the intake side, and that will fill in this area, forcing the exhaust to move out the exhaust port, okay, forcing all those spent gases out. Well, in a conventional two-stroke setup, this was all done with a fresh fuel and air charge. And so what that meant was a lot of that fresh fuel and air was going out the exhaust. It was just going out the exhaust, and that is why your muffler typically would be a little bit wet. You can see this all the time on dirt bikes and everything. That's because you are losing a significant amount of fuel out the exhaust port. That's why it's wet, okay? If you're ever taking a muffler off and you see it's wet, you've got fresh fuel exiting the muffler. And that's by design. That's actually supposed to happen. Well, what Husqvarna did is, instead of scavenging out all of those spent gases with fresh gases, let's scavenge them out with fresh air. Just straight air. And so what they did was they made the transfer ports pretty much twice as long. This right here is the so far unported cylinder off of one of my Red Max 5000s. And what you see is, I guess I've been going exhaust this way, so let's do it like this. Our intake is here, right? We draw in fuel, and then it comes down into the crankcase and ultimately gets pushed up the transfers and in like that. Well, this added length, normally it just goes straight right like this. In most saws, it goes from here straight up. Well, in the 5 series and in the steel Strato saws too, I believe all of them are set up similar. We come all the way from the carb down in, up the transfers, and then back around. You can't see that. Like that. Well, that adds a lot of length. Why is that? I asked this question a while back on the channel, and there were various different thought processes with it and everything. But what's happening is probably the first 40% of our transfers are actually charged with fresh air, right? That way, whenever we push in and scavenge all of the spent gases out and they flow out the exhaust, we're doing that with fresh air, and we're not losing fuel. We're not losing fuel and air mixture. And so that's better for the environment, right? Hoorah for the environment. And but that's what it's all about. That's what has caused this design. And a lot of people really balk at that and everything, and I understand it, but there are ways around it. A lot of people have tried to close off these intake ports, but that doesn't work. All right, it doesn't run right whenever you do that. And by intake ports, I'm meaning the Strato ports themselves. All right. So what's happening? Let me show you with the piston here a little bit. So the piston has these cutouts in it. Well, this right here is basically just a gate from our Strato ports to the transfer ports. So as this piston is going up, it's going up, right? These cutouts line up with the Strato ports. And then that creates a hallway, literally a little hallway into your transfers right here. And so that whole front portion of the transfer gets packed with air, nothing but fresh air. So then as the piston goes back, comes back down, and it's pushing all of the crankcase gases up through the transfers, the whole first portion of that is nothing but air. And that's what shoves our exhaust gases out the exhaust. Okay, all right, so now you've all heard stuff like this before. I think, maybe you haven't, But that's how they work in a nutshell. Okay? Maybe I'll add in so the animations and stuff. Maybe I've already added them in. I don't know. But when you charge your transfer, oh, okay. No, I see what I did here. I'm looking at notes is what I'm doing. All right, so with the 5 series transfers then, you need to start thinking of them a little bit differently. Number one, the big thing that a lot of people get hung up on is reversion. Whenever exhaust gases have too much power and they push down into your transfer ports. Well, with a setup like this, our entire first, 30-40% of the transfer is nothing but air. Fine by us if we get some reversion going down in there. That's not going to cause the big problem that it used to, where it was diluting our mixture of air and fuel. It's not doing that now because it's just going straight into air. So we don't give a shit about reversion like we did before, right? So now, and so that's your number one thing that people always talk about whenever they're talking about blowdown. They're talking about you need to have time for the exhaust to get out, and your transfer pressure is great enough to overcome the exhaust pressure and push it on out, right? Well, that just goes out the window because we're totally pretty okay with reversion, where the exhaust goes down into the transfers a little bit, right? Changes the game there. Also, we look at, on a typical situation, let's say we like to run 20 degrees of blowdown on a normal conventional saw. We go, I like 20 degrees of blowdown. It seems to work really good for me. Well, now the first 8 degrees of that blowdown is going to be wasted on nothing but air having to move through. So in order to get your saw to operate the way that it did before, whenever you were using 20 degrees of blowdown, you might need to actually change it up to 12 degrees of blowdown, because that entire first 8 degrees is just simply moving air through. That's it. All right. That's it. And so multiple reasons why the 5 series saws are using really short blowdown numbers if in fact you are porting for that and everything. And that is the whole first portion of your transfer is nothing but air, and we just got to get it out of there anyways. So that immediately takes your blowdown way short compared to what it was before. It has to be, because you have to have time to get to your good fuel air mixture. Now, let's talk a little bit about the good fuel air mixture. All right. At 12,000 RPM, the piston is moving up and down 200 times per second. Get that, up and down 200 times per second. So it's kind of like 400 times. So since we are really only introducing our fresh charge into the cylinder on the downstroke of the piston, we have to divide 1 second by 200 and then cut that in half. So our transfers are open for pushing fuel into our combustion chamber for a total of 4 1,000ths of a second. Okay, that's how long our transfers are open, for 4 1,000ths of a second. And that is, of course, based off of the number. My piston fell out. I'll get to that later. That's based on the numbers that I got with this 50cc cylinder. And so, let's see. Where's I at? So, okay. If the transfers are opening at 120 degrees, right, then you've only got from 120 degrees to bottom dead center, right, which is 180, right, That's all the time that you have for useful transfer, okay? Because whenever that piston starts going back up, that does not count as transfer, because pressures are starting to equalize and everything. You are no longer pushing charge up above. So you've only got from 120 degrees to 180 degrees, and that's when we're pushing our transfers open. Right? And that is if your transfers are opening at 120 degrees, which is pretty typical for this cylinder right here. Okay. So you got, that means that I've got 60 degrees to move a big chunk of air and then fully introduce my fuel and air mixture. It can't happen. I don't have enough time to do it. So we have to give it more time. We give it more time by raising the transfers, and that's whenever we get into territories that are scary for a lot of us, because we're like, are you serious? Oh my God. I just set my transfers to open at 110 and my exhaust opens at 100. That's only 10 degrees of blowdown. Or maybe even different than that. Maybe you're like going, I set my transfers to 114 and my exhaust opens at 106. And so you're like, I've literally only got 8 degrees of blowdown. Well, what I would suggest is quit thinking about blowdown, period. Because if you set these things up properly, your blowdown is pointless. It's just absolutely, incredibly pointless. And I am not sure, but I am thinking that, yeah, I'm already at 18 seconds, and I've got a lot more to talk about with this. So let's end it right here. Excuse me. And so we'll call this part 1, and then we'll pick up with part 2 in the next video. Maybe there'll be a part 3. I don't know. But that's all for now on this video. We're stopping right here.